CoreTest recognizes the difficult times that the pandemic presents to the industries it serves. Therefore, CoreTest has begun producing films to aid its customers in the deployment of its systems. The first introduction video will identify the key components of CoreTest's environmental load frame systems. Starting from the left of the screen is the servo, pictured with two black wires attached to it. This servo generates torque which gets multiplied by the 5-to-1 right-angled gear reducer attached to the servo. This turns the input shaft of the jack screw, painted blue. The jack screw turns the torque from the gear reducer into thrust, which causes a load to be generated on the specimen. The two silver structures attached to the jack screw are the limit switches. These stop the jack screw from traveling outside its operational limits. The large, flat black piece is the platen. The two columns, in chrome, support the upper platen. Attached to the platen in the center is the linear bearing. This prevents any axial stress from affecting the specimen. The load cell is attached to the linear bearing, painted blue. It senses the force generated by the jack screw. At the top center is the coupling. This allows for removal of the lid assembly. Below that is the LVDT holder. The LVDTs are secured by the two black knobs. LVDT stands for Linear Variable Differential Transformer and is responsible for recording the deformation of specimens inside the autoclave. Also pictured is the dial which shows the pressure inside the vessel as a backup to the electronic one. In yellow is the solution thermocouple. The lid and the body of the vessel, wrapped in a heater blanket. In gray, the controls. These allow an operator to jog the ram up and down. Also, an e-stop to disable heat and motion. To the right of that is the valve panel. This is the DCPD console and computer. The DCPD, or Direct Current Potential Drop System, consists of a nanovolt meter, a current source, and current reversing relays.